where should I start? Because I want to end up with teaching how to integrate ln x, right? But I don't know how far back we should go. Like, do I go back to differentiation or do I just start at integration? So you know what? We'll go back to differentiation, but just a small, like, just a quick summary kind of thing of integration. Alright, you've got a curve that goes like that. Pretend it's a curve, alright? You've got your... This is your x and y, right? Now you want to know where its stationary points are, which is this, and let's say the curve goes back down like this. Alright, so we've got we've got a kind of semi-cos curve, which isn't good. So let's say the curve actually just keeps going. Let's just say we've got two stationary points there and there, although technically you could argue that that could be a stationary point, but it would be a different kind of stationary point. It wouldn't be a minimum or a maximum stationary point. Nerd shit. Don't worry about it. So why you'd want to find the stationary point? Maths reasons. For whatever reason. Say you wanted, I don't know, the tangent or the normal to that point. You'd want that point, or you'd want the gradient of it. Right, actually no. So I'm going about this all wrong. You've got that's y equals x squared. Alright? That's the y-axis, this is the x-axis. Now, let's say you wanted to know what the gradient of a line would be that passes perfectly at this is y would be 4, 2, right? 2 squared is 4. Let's say you wanted to know the gradient of a line that passed through the point 2, 4, but didn't touch the rest of the line. That would be the tangent, which is a line that only touches one point on a curve or a circle, etc. How would you calculate that? Well, you'd say, well, I need another point so that I can calculate the gradient using rise over run. Well, you're wrong. Here's what you're gonna do. You're gonna differentiate the equation y equals x squared. Now, there's a lot of weird, funky, cool, quirky maths, differentiation by first principles, etc. You can find that out for yourself. It's worth just reading some like Wikipedia articles and pages and things for fun. I have a life, I don't know what you're talking about. But basically, this just means differentiate, alright? dy by dx. Don't ask any questions about it, you're better off not knowing. Equals 2x. Now, do you notice a link between them? Do you see anything that could link the two? I know. What you do is for any function squared, right? Let's say you do x squared plus 5x plus 5. For any function, you minus 1 from the power and times by the power. Right? Now, for the plus 5, you'd say, well, what's that? Well, as we all know, x to the power of 0 equals 1. Or maybe we don't know that. So, let's prove that. Okay. Oh, let's go out a tiny bit more. Actually, can I switch you to the lowest? No, I don't like that. We'll keep you at 3 pixels. Alright. So, X squared divided by x. What does that equal? Well, let's try 25 divided by 5 equals 5. That's not a 5, that's a 1. 5. Alright, so what do? You do that equals x. It equals x, right? I'm just... fuck all of this. Just get it out of the screen. If you do x to the 5 divided by x squared, what you do, any division, you minus the powers, any multiplication, you add the powers, except if they're in brackets, like x squared within brackets to the power of 2 is... no, sorry, to the power of 5 is x to the 10, not x to the 7. So this would equal x to the 3. Now, 5 divided by 5 equals 1. Yes? So, x divided by x... fuck you. X divided by x equals 1. Now, how else can you write that? X to the 1 divided by x to the 1. So you do x to the 1 minus 1 equals 1, which means x to the 0 equals 1. Great. Cool. Exciting. Lots of people already do this. It's fun. It's cool. But the first time you learn, it's always a bit quirky and exciting. But then, so you've got 5 times x to the 0. To the 0. I need you to expand further out this way. Por favor. So you minus 1 from the power, and then you times by the power. So anything times 0 is 0. So these all cancel out. This becomes 2. Why do I have a 2 there? There shouldn't be a 2 there. This becomes 2x, right? This becomes 2x plus 5, because we've got x to the 0 times 5, right? That's all cool and dandy. And what does it give you? That gives you the gradient at a point. So on the curve x squared, right? If we want the gradient at the point 2, 4, you just slam it in there. dy by dx equals 2 times 2. So the gradient equals 4. So you do y equals 4x plus c. You do 4 equals 4 times 2 plus c. 4 minus 8 equals c. c equals minus 4. So the equation for the line that passes through 2, 4 and is a tangent to the curve x squared is y equals 4x minus 4. Wonderful. Exciting. Beautiful. Brilliant. Why don't you give me a larger erase? How do I hate you? Can I just like select? Okay, I'm gonna select, and can I just delete? I've never used this before. Okay, fuck me, I guess. I'm just gonna spam Control Z. That's fine. No, you know what? It's not fine. We're going over here. We're going all the way over here. And now I'm going to teach you integration. So, differentiation is... differentiation, right? Now, integration is the opposite. And how do we... So, oh, wrong thing. This one? No. This one? Yes. Okay. dy by dx is for differentiation. So what do you do for integration? You do a little cool s. It's got a fun name. We don't care. Alright. So you've got your x. Fuck you. You've got your... Fuck you. You've got your x squared. No. Y equals x squared. Now, we differentiate that. And what does differentiate give us? integration. Fuck, we integrate that. What does integration give us? Let's say you want the area under the curve, so all of this bit between x is 0 and x is 4. We write them lower bound, upper bound. Integration will give you that area there. Now, what is integration? Integration is the opposite of differentiation. So if you minus 1 from the power, and so if you times by the power and then minus 1 from the power, what would you do? You add 1 to the power and then divide by the power. So you do x cubed over 3. Add 1 to 2, divide by that. Right? Cool. Fun. Funky. Exciting. And you want to prove it? Well, then let's just differentiate that. X cubed, you times by the power, you get x cubed, and then you minus 1 from the power, you get x squared. So they work both ways. Wonderful, exciting. So then you plug that in. How do you plug that in? You do the upper bound, 4 cubed over 3, minus the lower bound, 0 cubed over 3. So what's that? It's 4 cubed over 3. I don't have my calculator, I'm not doing 4 cubed. It's whatever 16 times 4 is, that's 64. Never mind, I beat you to it. It's 64 over 3. Exciting, delightful, wonderful, brilliant. Yada yada fucking yada. That's integration. We're speedrunning this shit though. So let's chuck in some more functions, because currently we've just been doing x, right? Well, what about cos x? Can you differentiate that? Can you? Well, yes, the answer is yes. What's the differentiation of cos x? It's negative sine x. What's the differentiation of sine x? It's cos x. So what you'll notice is you differentiate sine x, you get cos x. You differentiate that a second time, you get negative sine x. You differentiate that a third time, you get negative cos x. You differentiate that again, you get sine x. These ones will kind of cycle back on each other. But what if you have cos x squared? Well, now I didn't really go into this, but you've got now a function within a function. So what you do is you differentiate the outer function, you get negative sine x squared, and then you times by the differentiation of the inner function 2x. So it's negative 2x sine x squared. Great, that's cool. Then we get to logarithms. Logarithms are fun. They're just for calculating, you know, say 2 to the x equals 4. Now we know that 2 squared equals 4, so we can say that x equals 2. But what if you had 2 to the x equals 5? We know that 5 isn't within the things of 2. So what you do is you do either log or natural log. I prefer natural log. Ln 2 to the x equals ln 5, and what this means is you bring the power down, you times it outside the brackets. So you have x ln 2 equals ln 5, x equals ln 5 over ln 2. You chuck that in your calculator, you get your answer. It's whatever it is. But now let's say you have an equation that's ln x squared. Oh no! Now you have to that's a squared. Now you have to deal with all of that. That's terrible. Luckily, it's the same thing. So ln to the 1, no, ln to the x. You differentiate that, you get 1 over x. All right. Now, so ln is differentiated is 1 over whatever's in the bracket. So you differentiate that, and then you times by that, which is 2x. Cool, you're getting the hang of it. I'm proud of you. Really, I am. You're doing great. But now we get to integration, and so integration can get. Oh, fuck. We need to go over one more thing. What if you have cos x sine x? So that times each other, right? Now what you have is you have two functions times each other. Normally you had a function times a constant at most, like 2x. Now you have two functions. You don't just differentiate both of them and times them by each other. If you want to differentiate no, we'll do uv by dx, right? What you want to do is you want to differentiate u v plus u differentiation of v. That's a different notation. Y dash means differentiated, 2 dash means double differentiated. That's fine, don't worry about it. It's all good. So what you do cos equals u, sine equals v. Cos differentiates gives you negative sine. Well, just negative sine times sine gives you sine squared x. That's a 2. Then you do plus. Sine differentiated gives you cos, so you get cos squared x. It's cool, it's fun, we're living, we're laughing, we're loving, that's great. So we get to integration, right? You wanna integrate negative sine x. You remember, oh well, cos x differentiates into sine x, so negative sine x differentiates into cos x. It all makes sense now. It's great. It's dandy. It's fun. We're having a great time. But then I tell you, well, what about differentiate this one? And it's like, oh no, those are two different functions. This is terrible. This is terrible. Everything's gone to hell. It's all terrible. I'm crying. You can see, these are my tears. I am crying right now as we speak. That was actually probably a bad choice. Okay. It's all good. It's all good. We're gonna change it. We're gonna 2x sine x, because this is just for an example. It's just for an example, okay? You're gonna go, well, there's two functions. You can't, neither of them come from the other, so it doesn't work out. So, what you're gonna do, you're gonna reverse your, what we call the product rule, with the cos x equals, your uv equals u dash v plus uv dash, right? So what are you gonna do? You're gonna do uv dash equals uv minus the integration of v u dash. Right. That all makes some sense because uv equals differentiated as vu dash and uv dash, right? You're just going to integrate both of them. So what you need to do is you need to choose one of these to be your u. We're going to choose 2x to be our u. We're going to choose our v dash to be our sine x. So then we need to integrate sine x. So we get v. I knocked my microphone over in my excitement. Don't worry, everything is good. Sine x. Right? We remember that negative sine x equals cos x. So then positive sine x must equal negative cos x. So negative cos x is our v. And then we just chuck it all in here. So we do negative 2x cos x minus the integration of a negative cos x times, we differentiate 2x, we get 2. That's so exciting. So you get negative 2 cos x. Now negative cos x equals sine x. So we get, negative cos x equals negative sine x, sorry. So we get our negative sine x, but then we're like, well, you differentiate this, you get your negative cos x. Where does our negative 2? Luckily, 2 is a constant, not a function, so we can just chuck it right in there. So then we expand out, you know, we have negative 2x cos x minus 2 sin x. We get negative 2x cos x plus 2 sin x. And if you wanted to differentiate all of that and expand it all out and do all of the shit, you'd find out it equals 2x sin x. Oh, we should also add a plus c, because you'll notice that 2x, right? Well, no. We'll do it the other way. X squared plus 5 and x squared plus 3. Both of these x times 0, so when you differentiate it, you do 0 times 5, you get 0, you do 0 times 3. Both of them equal 2x. So when integrating, you add plus c, meaning plus constant, which, you know, some questions will ask you to solve, etc. But that's all of that shit. We're all happy, we're living, we're laughing, we're loving. Right? So now I'm gonna ask you, you know, what's the integral of ln x? And you're like, well, I don't know, you haven't told me. And that's where I've got you, because you're gonna prove it. You know how you're gonna prove it? We're gonna do it right now. Is that the... No, okay, no, yeah, that's all good. Never mind. Forget I said anything. I'm all good. How are we gonna prove it? Well, we don't know the integration of ln x, because nothing, your sec, your cos, your tan, your secant, your, I already said secant, your cosecant, your cotangent, your tangent, your, all of your logs, none of them will end up differentiating to ln x, so there's nothing to integrate back to from ln x. So we're going to use our product rule. And how are we going to do that? Well, you might be saying, well, there's really only one function, ln x. And I'd be like, well, you're correct. However, have you perhaps considered mic drop ln x times 1? That's just a constant, you say, but you can integrate it. x0 equals v dash, ln x equals u. V dash, you integrate it. Add 1 to the power, divide by the power. 0 plus 1, that's 1. Divided by 1, that's 1. V equals x. You chuck it all in your formula. You've got your x ln x, right? Your uv minus the integration of x times, you differentiate ln x, you get 1 over x, so you get x ln x minus the integration of x0, x ln x minus x. And if you integrate all of that out, if you differentiate all of that out, you'd get ln x. And that, my dear friends, is how you integrate ln x. Admittedly, I've condensed like a term's worth of learning at school into like 20 minutes, so a lot of the wow, very exciting, very cool, that's so cool, I'm fascinated by that, doesn't really come through. We're gonna solve the equation. ln x plus 5 equals 5 plus ln x. Let's just go over logs. The normal log. So what a log does, I don't really go quite in depth enough. log base b to the x equals b. Now what does that mean? For a log, you choose its base, b. Well, theoretically. In calculators, you really only ever have log 10, which is just referred to as log, or log e, which is referred to as natural log. And e is Euler's number, and it's a pretty fun, quirky little guy. Now, what this means is you set the base b is b to the power of b to the power of x equals 5, right? You want to know? No. We'll go back to what was it? Right. 2 to the power of x equals 5. You want to know what 2 to the power of x is? If you do log base 2, so log 2, these will cancel out, because 2 to the power of x, when you want to know what, so let's change it a bit. We'll go 2 to the power of 5. No. 2 to the power of 4. No. 2 to the power of 3. I can remember 2 to the power of 3. That's 8, which is 8, right? So you do log 2, 8 means 2 to the power of what equals 8, and the answer is 3. So it's for working with indices, etc. So you want to know 2 to the power of what equals 5. So you log base 2, 5, and you get x equals log base 2. However, with calculators, you really only have log 10 and log e, and what you need to remember is like the kind of ratio, I guess. 10 to the power of x equals 2 and e to the power of x equals 2. The ratio, like it's kind of the same, kind of. So if you have two sides, 2 to the x equals 5, then and you rearrange it. So you do log base 10 2. You need to remember, like, factors will just get pulled out. If you had log brackets 2 times 5, it could also be written as log 2 plus log 5 because of nerd shit. You have so you have your I'm a terrible explainer, and it's been a while since I've done this, so you have to forgive me. I don't know why I've decided to do this. No one would willingly watch someone teach maths. I didn't enjoy watching someone teach maths, but I enjoy maths. I love maths. Maths is fun, okay? So you don't have a right, you don't have a say, you mean nothing to me. We're gonna rewrite that. Log 2 equals log 5. X equals log 5 over log 2. Now, that is the same as ln 5 over ln 2, and it's the same as log 25 over log 22. Basically, you need to remember that, like, because of weird shit, the ratios will always be the same. So that's important to remember. And then you also need that's it, right? So if you have ln e to the x, these will cancel each other out, because that's, e to the x, what e to the x is, this is what ln is asking, and e is saying, well, it's x, so they cancel out, you get x. Which means that we've got ln on both sides. You have ln x plus 5, and 5 plus ln x. So ln has happened on this whole side as well, which means that how come the ln cancelled out of that? Well, that's because this equals ln e to the 5. Now, you have ln x plus 5 equals ln e to the 5, that's a 2, plus ln x. Now, some nerd shit, which maybe if I have to wait for even longer I'll teach. Log plus log is the same as log something in brackets plus log something in brackets is the same as log something in brackets times the other something in brackets. So you can do ln x plus 5 equals ln, I'll add the brackets, e to the 5 times x, and now you can notice, well, these are both ln, so you can assume that the things in brackets are equivalent. X plus 5 equals e to the 5x, and then you you'd move the e over, you have x minus e to the 5x plus 5 equals negative 5. And then we want to just refactorize the x out. You have x1 minus e to the 5 equals 5. X equals 5 over 1 minus e to the 5. We're going to do x to the power of 5. We're going to do 5x to the power of 5 minus x to the power of 4 plus 3x to the power of 3 minus 7x squared plus 8x plus 8. And let's say I wanted to divide this by x squared minus 1. And you may be thinking to yourself, well, I don't know if that's possible. I don't know if you can divide this, because you don't know what x is, so how can you divide it? Well, my friend, it's genuinely actually kind of simple. You've just gotta use your brain, which unfortunately not many of us have these days, because we live in a society Batman. What you're gonna do, you're gonna remember back in, I don't know, year 7 or whatever, you did your division shit, you did all of that fun stuff. You know, you had to do your long division kind of stuff, you wrote it out like this, it was lovely and fun, and you were having a great time. That's a lie. You write it out like this. You divide by x squared minus 1. You're like, well, how am I gonna do that? You're gonna look at each individual term. You're gonna look at 5x to the power of 5. You're gonna say, alright, 5x to the power of 5 times, we've got our equals something times x squared, right? You're gonna look at that, you're gonna say, alright, 5x to the power of 5 divided by x squared gives you 5x to the power of 3. That's your first factor, right? We're gonna end up with two brackets, x squared minus 1, and whatever's in here. That's great, that's lovely, we love that, we love learning, we love maths, it's all fun, right? So then, what you're gonna do is you're gonna say, well, okay, 5x to the power of 3 times x squared gives you 5x to the power of 5. So you're gonna minus that from this. That's not an x. Why did I do that? Minus this, right? You times that, right? Just to make it easier. And then you're gonna do 5x to the power of 3 times negative 1 gives you minus 5x to the power of 3. But you're gonna minus that, so that's minus minus, which is a plus. That's not a plus. I'm gonna redraw my plus. 5x to the power of 3. You're gonna do all of that. You get negative x to the power of 4 plus 8x to the power of 3 minus 7x squared plus 8x plus, I'm gonna pretend that's an 8 In fact, I'm gonna pretend I know that that's an 8. Right? And then you're gonna do it again. Negative x to the power of 4 equals what? Times x squared. That's negative x squared. You times that out, you get plus x to the power of 4, and then you do minus x squared times negative 1 gives you positive x squared, so you minus it minus x squared. I heard a... Oh no. Oh no.